Hi all, let's discuss about the in-order traversal of the tree with the help of recursion. So, we have few steps to be followed in order to achieve the in-order traversal operation. So, the first step is we have to keep moving towards the left-hand side of the root node and we'll be keep doing until the left reference of the current node will not be pointing to null. Once it is start pointing to null, so then we will be printing the current node value, that is left node value. The second step is we will be printing to the root node of the left node value, and the third step is we will be printing the right node of the left root node value. So once that is done, so base case will be executed, and the base case is once the current value will become null. Now let's discuss about the in-order traversal implementation with the help of recursion. So for that we have already created a binary search tree, and this is the outcome of the program which we are expecting from in-order traversal operation, and will be start traversing from the root node which is currently holding the value 50, and we will be traversing towards the left node of the root node, that is 35, and we will be keep moving towards the left node until the current left node will not be pointing to null. So we will be keep traversing towards the left node from 50 to 35 and 35 to 20 and then 10. Now you can see 10 left is pointing to null. It means we won't be going further. We will be returning back from here and will be printing 10, because we will be printing first left node and then root node and then sorry then node itself. It should be denoted with n and then right node. All right, so we have printed left node. Now I will be backtracking to the previous place, that is 20. Now we'll be printing 20. So we have printed 10 and then we have printed 20, right? So this is done, this is also done. All right, now from here we will be checking the right hand side node of the current node. So current node we have 20 and the 20 right side node we have 30. So here we will be checking the left node first. Left is null, we'll be returning back and printing 30, and right is also pointing to null, so current control will backtrack to 20 again, and we have printed 30 here. Now from 20 we'll be routing back to previous node, that is 35, and we'll be printing 35. 35 is here. Now from 35 we'll be checking the root node, sorry, right node, because left is done. Whatever nodes are present uh, under the 35, that is traverse already. Now we have to take care of right node of the node 35. So it is currently pointing to 40, and 40 left and right both are pointing to null. So we are printing only 40 here after 35, and then we will be control will backtrack to the 35. 35 is already done, and 35 left and right is also done. Now we will be moving back to 50. So 50 we have not printed. Now we will be printing 50 here after 40. All right, that is root node. Now all the left node of the root node, actual root node is traversing is done. Now we have to take care of right side nodes of the root node. So let's execute that as well. Now from here we'll be moving towards the right hand side, and we'll be checking whether 60 is holding any left node. Yes, it is having. So from here we'll be moving to the left hand side, and it has 52. From 52 there is no any left or right, both are pointing to null. So we will be printing 52, and then we'll be returning back. Control is will be returning back to 60. Now you can see 60, and it will be printing 60 because First we are printing the left node and then root node and then right node. So 50 we have already printed here, and then comes to its root node. So we have printed that as well. Now comes to its right node. So control will be going towards the right node of the current root node, that is 60. So 60 right is 70, and from 70 also, as it is a root node for the its child, so we will be checking whether any uh, child of the 70 70 is present or not. So 70, there is no any child. 70 itself is a child. So we will be printing 70 considering it's a child only, and control will be returning back to 60. So 60 we have printed already because it's a root node, and after left we'll be printing root node and then right node, right? So we have printed left, root and right. All right. Now we'll be returning control back to base, right? So control go back to base case, which is root node, and from here there is nothing inside the stack which we have to take care of, and then the reference will be here pointing to null. So once it is pointing to null, our base case will be executed and program execution is done. So now you can see this is the complete output of in order traversal operation. This is what we are expecting from this program, and uh, this is a graphical representation discussion. Now let's get started with the backend code. So for that, we have already created a class called InOrder Traversal, in which we have mentioned a couple of things. So the first one is input. Input element of integer type we are going to use to build a binary search tree. And this is the binary search tree itself, which we already talked about in the graphical representation discussion. And expected output is the output which we are expecting from this in-order traversal operation. And another one, actual output, is the one which this program is going to be produced, and the produced output we are going to keep it here so that we can compare the actual output and expected output. Now let's get started with the coding part without any further delay. So let me create a private method. In order traversal is a method name, and method input parameter will be current of node type, which will be holding the reference of current node. So here our base case will be if object value is current value is null. In that case we have to return control back to previous node. In case if current is pointing to any node, in that case we have to make recursive call by passing left node first, and then we will be printing the data. Sometime it will be printing firstly it will be printing left node data, then root node data, and then right node data, and after that we have to make another recursive call by passing right node. So uh, this was the small set of implementation for in-order traversal operation. Now let's quickly create a main method, and we'll test whether our this in-order traversal operation is working fine or not. Now we'll be taking a help of builder tray implementation, which we had uh, done in first or second tutorial of the tray series. By build method will be returning root node, and then we will be calling in order traversal method by passing root as input parameter. Alright, okay, we are passing the actual data, but we forget to add separator here. Now let's see.
Now let's compare this output with the expected output. Okay, so this is the actual output which this program is producing, and we'll be comparing that with the expected output. So this 10, 20, 30, 35, 40, 50, 52, 60 and 70. So this output, expected output and actual output is working fine, just that there is one another arrow as a separator in actual output, but that is fine. Just that we need to make sure that our expected and actual output for the element is uh, equal. So it is equal, and it mean our program is working fine. So that's all from this video, guys. Thank you so much for watching.